Static stability. Stability is the capability of a body to return to its original condition after a disturbance. A body has positive static stability when it returns to its previous condition after a disturbance. Positive static stability. A body has positive static stability when it returns to its previous condition after a disturbance. It is important for an aircraft to have positive static stability. An aircraft must have positive static stability. For example, in turbulence, the aircraft must be able to follow its flight path without allowing rough air to provoke any significant change in its flight path. This must happen without any intervention from the pilot and with no variations in the position of the control surfaces. Neutral static stability. A body has neutral or indifferent static stability when it maintains its new position after a disturbance. Negative static stability. The third type of stability is negative static stability. A body has negative static stability when it continues to move away from its previous condition after a disturbance. Static stability summary. Positive when a body returns to its original condition after a disturbance. Neutral when it maintains its new position. Negative when it continues to move away from its previous condition. Dynamic stability. Consider first a system that is statically stable. One possibility is that, having been displaced from equilibrium, the system will, under the action of the forces created, simply subside gently back to the original condition and remain there. If so, the system is said to be dynamically stable with aperiodic damping. However, the system may, when it reaches the equilibrium point, do so with a certain velocity so that it overshoots. The new forces will now, since it's statically stable, retard the system so that a sequence of oscillations occur in a periodic motion. A statically stable aircraft affected by a disturbance will oscillate around its intended flight level. Positive dynamic stability. If the period remains the same in length and the amplitude continues to decrease, the dynamic stability is defined as positive. A body has positive dynamic stability when it returns to its initial condition through a series of periodic equal time oscillations of decreasing amplitude. Neutral dynamic stability. An aircraft has neutral dynamic stability when its oscillations continue without any change in amplitude. Negative dynamic stability. An aircraft that oscillates with constant periods but with increasing amplitude after the disturbance has negative dynamic stability. An undamped oscillation cannot be acceptable for an aircraft. The normal requirement is, after one oscillation, the angle of attack should only be 1/10 of that at the beginning of the disturbance, and that the oscillation should be completely damped after approximately 2 oscillations. CG and centre of pressure. The centre of gravity is the central point of the exerted weight and the centre of rotation of a body. The location of the centre of gravity with respect to the neutral point determines the longitudinal stability of an aeroplane. The centre of pressure changes its position at different angles of attack and moves towards the leading edge when the angle of attack increases. Moment and stability of the isolated wing. The effect on the whole wing acts on the mean aerodynamic centre. The turning moment of an isolated wing is dependent on the location of the aerodynamic centre in relation to the centre of gravity of the wing. When the aerodynamic centre is located in front of the centre of gravity, the aerofoil will rotate in an unstable manner. The turning moment around the CG is the product of the force multiplied by the distance between the centre of gravity and the aerodynamic centre. Moment equals force multiplied by arm. With the turning centre in front of the lift force, the wing will be stable. The wings are not the only aerodynamic surfaces that create turning moments. The fuselage and tail surfaces also generate a centre of pressure. When designing a statically stable aircraft, the wing has to be located on the fuselage in such a position that the centre of gravity of the entire aircraft is at the centre of pressure in steady flight. In this situation, the sum of all forces and moments is zero and the aircraft is in trim. In order to have a stable aircraft, the centre of gravity of the entire aircraft must be in front of the aerodynamic centre. Aircraft usually have positive static stability by having the centre of gravity of the entire aircraft in front of the aerodynamic centre. Longitudinal stability. Longitudinal stability is measured in the fore-aft axis. On a conventional aircraft, the horizontal stabilizer provides the main stabilizing force. To be longitudinally stable, the aircraft must have the tendency to return to trimmed angle of attack after any disturbance without being influenced by the pilot. Balanced forces. The total weight of the aircraft is 13,500. The tail down force is 500. These combined produce a wing fuselage lift that's required of 14,000. Balanced forces with gust. If there's a gust and the centre of gravity is in front of the aerodynamic centre, a tail down force decreases and a stabilising nose down moment is created. If the centre of gravity is closer to the aerodynamic centre, there's a shorter moment arm. There's still a greater nose down moment than nose up moment, but there's only a small stabilising nose down moment. With the centre of gravity coinciding with the centre of pressure, there's no stabilising turning moment. There's a danger of the aircraft being neutrally statically stable. The neutral point. When the CG is at a certain position compared to the wing fuselage centre of pressure, the aircraft will not receive a sufficiently stabilised moment from the tail surface. It will remain in the new attitude instead of turning back to its previous position. Consequently, when the CG is located too far aft of the centre of pressure of the wing, the CG and aerodynamic centre of the aircraft could coincide and the aircraft will be neutrally statically stable. The point along the longitudinal axis where the position of the CG causes neutral or indifferent stability is called the neutral point. The aircraft is unstable when the CG is after the neutral point. When the CG is positioned after the neutral point, the increase in stabilizer lift is not great enough, thus a destabilizing moment is created. The whole aircraft becomes unstable. It pitches up, causing a higher angle of attack, which creates a further increase in lift and a greater nose-up moment. An unstable aircraft shows a natural tendency to diverge from trim flight attitude. If the CG is positioned behind the neutral point, the aircraft is statically unstable. Static margin. To assure good longitudinal stability, an aircraft is usually designed to avoid the CG being too close to the neutral point. The distance between the CG and the neutral point is a direct measure of the longitudinal static stability. The distance between the CG and the neutral point is called the static margin.